Hello everyone, welcome to my YouTube channel. Myself Hardik Shetty, currently pursuing in second year engineering in Sri Venkateswara College of Engineering, Vidyanagar, Bengaluru. Today we are going to discuss about a research paper which holds the title Wide Data Structures. As we know, the research paper title is Wide Data Structures. It was published in International Journal of Scientific Research and Engineering Trends in Volume 7 and Issue 3. The author of the research paper is M. Amita Reddy. The agenda of this paper explores the definition and importance of data structures in the field of computer science. We will also see the chief grounds of using various data structures. The study of data structures helps us to understand how data is organized and how data flow is managed to increase efficiency of any process or program. They also provide various methods to organize and represent the data within the computer's memory. Different types of data structures are examined in this paper. This paper begins with an overview of data structure and its types. It then examines their main application and concludes with the necessity of data structures in the computer science specialization. This paper is the result after a detailed research under the situation of absence of data structures. The first topic is introduction. The data structure represents logical relationship that exists between individual elements of data to perform a specific task. The term data refers to numerical or other information represented in a form suitable for processing by a computer. Structure can be defined as the way in which parts are arranged or put together to form a whole. A data structure can be also be defined as the combination of data and all the potential operations which are required for those set of data. The basic data items includes bits, characters, and integers. Data structure deal with manipulation and assembling of data. However, the data available is usually in the amorphous form. When different type of such amorphous data related to each other, we refer to it as a data structure. Data structure can be classified into two categories: primitive data structure and non-primitive data structures. The first one is primitive data structure. Primitive data structures consist of the numbers and the characters which are built in programs. This can be manipulated or operated directly by the machine level instructions. Basic data types such as integer, real, character, and boolean come under primitive data structure. These data types are also known as simple data types because they consist of characters that can be divided. Integer is used for integral or fixed precision values. It is denoted as int. The type integer includes a subset of whole numbers whose size may differ in different computer systems. Character is used for character values. It is denoted as char. The standard type char consists of a set of printable characters. The type char comprises 26 uppercase letters, 26 lowercase letters, 10 decimal digits, and a number of other graphic characters such as punctuation marks. The subset of letters and digits are structured and contiguous. The type boolean is used for boolean values. The standard type boolean values are denoted by two identifiers, true and false. The boolean operators comprise logical conjunction, disjunction, and negation. The next one is non-primitive data structure. Non-primitive data structure are those that are derived from primitive data structure. These data structures cannot be operated or manipulated directly by the machine level instructions. They focus on formation of set of data structure elements that is either homogeneous or heterogeneous. These are further divided into linear and non-linear data structure based on the structure and arrangement of data. The first one is linear data structures. A data structure that maintains a linear relationship among its elements is called a linear data structure. Here the data is arranged in a linear fashion, but in the memory the arrangement may not be sequential. Array, list, stack, and queue come under the linear data structures. The first one is array. In general, it refers to an orderly arrangement of data elements. Array is a type of data structure that stores data elements in adjacent locations. Array is considered as linear data structure that store elements of same data type. Hence, it is called as linear homogeneous data structure. When we declare an array, we can assign initial values to each of its elements by enclosing the values in braces. Arrays can be classified as one-dimensional array, two-dimensional array, or multi-dimensional array. One-dimensional array means it has only one row of elements and it is stored in an ascending storage location. If an array consists of multiple rows and columns of data elements, it is also known as matrix, is called as two-dimensional array. Multi-dimensional arrays can be defined as array of arrays. Multi-dimensional arrays are not bounded to two indices or two dimensions. They can include as many indexes as required. The second one is linked list. A linked list is a data structure in which each data element contains a pointer or link to the next element in the list. To linked list, insertion and deletion of the data element is possible at all the places of a linear list. Also in linked list, it is not necessary to have the data element stored in the consecutive locations. It allocates spaces for each data item in its own block of memory. Thus, a linked list is considered as a chain of data elements or records called nodes. Each node in the list contains information field and a pointer field. The information field contains the actual data and the pointer field contains address of the subsequent nodes in the list. Linked list is of four types: single linked list, circular linked list, double linked list, and double circular linked list. A single linked list is formed when many nodes are linked together to form a chain. Each node points to the next node present in the order. A circular linked list is similar to single linked list, but the last node points to the first node in the list. A double linked list is a sequence of elements in which every node has a link to its previous node and next node. Here the node is divided into three parts. The first part of the node stores the address of the previous node, second part stores the data, and the third part stores the address of the next node. A double circular linked list resembles double linked list, but the last node pointers to the first element in the list. The third one is stack. A stack is an ordered list in which data items are inserted and deleted only from one end. It is also known as last in first out list because the last element which enters the stack will be on the top of the stack and is the first one to come out. The two main operations of stack are push and pop. Elements are added into stack by push operation and are deleted by pop operation. Stack is implemented using array and linked list. The below is an example of stack. In the example, element FF is the top of the stack and element AA is the bottom of the stack. Elements are added to the stack from the top. Since it follows last in and first out pattern, EE cannot be deleted before FF is deleted. And similarly, DD cannot be deleted before double E is deleted, and so on. The fourth one is queue. Queue is a linear data structure which follows first in first out order. In queue, data elements are inserted from one end called where end and deleted from the other end called front end. The queue in which the where end is connected to the front end is called as circular queue. Below is an example of queue. In this example, 55 is the front element and 65 is the where element. Elements can be added from the where and deleted from the front. The last type is nonlinear data structure. Nonlinear data structure is a kind of data structure in which data elements are not arranged in a sequential order. There is hierarchical relationship between individual data items. Here, the insertion and deletion of data is not possible in a linear fashion. Trees and graphs are examples of nonlinear data structures. Among nonlinear data structure, the first one is tree. A tree is a nonlinear data structure in which data is organized in branches. The data elements in tree are arranged in a sorted order. It imposes a hierarchical structure on the data elements. Each value or key in a tree occurs only once. That is, there are no duplicates. In a binary tree, each node contains at most two children. The second one is a graph. A graph is also a non-linear data structure in a tree data structure. All data elements are stored in definite hierarchical structure. In other words, each node has only one parent node. While in graphs, each data element is called a vertex and it is connected to many other vertices through connection called edges. Thus, a graph is considered as a mathematical structure which composed of set of vertices and a set of edges. The last topic is applications of data structure. Storing list of data elements belonging to same data type, auxiliary storage for other data structures, storage of binary tree elements of fixed count are the applications of arrays. The applications of linked list are implementing stacks, queues, binary trees, and graphs for predefined size. Implement dynamic memory management functions for operating system, polynomial implementation for mathematical operations. The third one applications are temporary storage structure for recursive operations, auxiliary storage structure for nested operations, function calls, deferred, postponed functions, managed functions are the applications of stacks. The applications of queues are it is used in breadth search operations in graphs, job scheduler operations of OS like a print buffer queue, keyboard buffer queue to store the keys pressed by users, job scheduling, CPU scheduling, and disk scheduling. Implementing the hierarchical structures in computer systems like directory and file system, and implementing the navigation structure of a website and code generation like Huffman's code are the applications of trees. Representing networks and routes in communication, transportation, and travel application, and routes in GPS, interconnections in social networks, and other network-based applications are the applications of graphs. Next, the references of this research paper. Advanced Data Structures, Theory and Applications, Classic Data Structures, Computer Programming, Data Structure and Algorithms, Basic Concept, Data Structure and Algorithms in C++, Data Structures using C, Fundamentals of Data Structure in C, Open Data Structures, What you should know about data structures are the references. And that's all for this video. Thank you. For more videos, subscribe to my channel and like this video. Thank you.